This is question 3 from the CCEA Maths A2 Pure paper from 2022. As I said, it's question 3, so let's take a look at what we have. So the first then is going to be a trig identity. So they have sec 2 theta cos theta and equals this. So you can start with either side really, whatever you fancy. I'm going to start with the left hand side and see what we can do. We have a sec 2 theta here, and we've only cos's over here, so I know sec is 1 over cos, so I'm going to change this then to this. So that's going to be 1 over cos 2 theta cos theta. I can then of course bring that cos theta up to the top, so it's going to be cos theta over cos 2 theta, and we're trying to make it look like a right hand side, so we're doing okay with a cos theta on the top, that's good. And then of course this is just a double angle formula, so we just change it then straight to that. So cos theta all over 2 cos squared theta minus 1. Remember, for your cos double angle formula there's 3 different options, and that's one of your options there. So that's part 1 of A done. It then says, hence find the exact solutions of this equals 1 between 0 and 2 pi. So we've just worked out that this here, do you see this from the previous question, is the same as this. So I'm going to put this here equal to the 1 and then try and solve it from there. So my first line is going to be just stolen from part 1, and it's going to be cos theta all over 2 cos squared theta minus 1 equals 1. And some people can see what's coming up here anyway, so this is just going to be then a trig equation to solve. Going to times through by the bottom line. Cos theta is equal to 2 cos squared theta minus 1, and then we're going to solve this like a quadratic. So I'm going to take this over to this side here, so it's going to give me 2 cos squared theta minus cos theta minus 1 equals 0. People do these different ways. Some people like to, let x equal cos theta and then just solve it like a nice easy quadratic. Then you change it back then at the end, or if you fancy it you can just kind of put it straight in. But whatever way, we just have a quadratic here that we need to factorize or solve, and so this factorizes and it gives us 2 cos theta plus 1 and cos theta minus 1. If you're watching this video, I really hope you know how to solve and factorize quadratic equations, so hopefully that's not too much for people and we can deal with it then from there. So we have then, that gives me cos theta is minus a half, putting that one equal to 0, or cos theta equals 1. So there's a couple of different options then for this, so I'm going to do the wee cast diagram here and then we'll chat about this one in a wee second. So here's my cast diagram here. So we C A S T 0, remember that's 90, but it's going to be pi over 2 because we're in radians. That's going to be pi, that's 3 pi over 2, and then that's going to be 2 pi. And we want to find in our basic angle, and maybe we should have done that above. So our basic angle, again, people do this different ways. I get rid of the minus and do cos the minus 1, and that then would give me 60 degrees, but in this scenario then it's going to be pi over 3. But I want to know where cos is negative, so cos is going to be negative here and it's going to be negative here. So actually the two ones I'm looking for here is this here and this here. So those are the two angles I'm looking for. So that's pi over 3. That one then is going to be 2 pi over 3. And then another 120 degrees, or another kind of 2 pi over 3 then from there is going to give me 4 pi over 3. Cos theta equals 1. I think we get into a weird world here whenever you try and do the cast diagram because you're along one of the angles. What I like to do, if cos or sine is equal to 0 or 1 or minus 1, I like to just kind of draw the graph. So the graph of cos between 0 and 2 pi I know looks like this, and you should too. That's 2 pi there, that's pi over 2, and that's 3 pi over 2, and it hits 1 here and it hits 1 here. So where is it 1? It's 1 at 0 and it's going to be 1 then at 2 pi. So my two answers for this one then are 0 and 2 pi. So my final bit then is theta is 0, 2 pi over 3, 4 pi over 3 and 2 pi. Okay, part B then. A new ice cream shop is open and designers create a logo as shown in figure 1 below. So we have this, two congruent triangles, which triangles are the same, together with that. This distance here is 6 root 21, this distance is 60, this distance is 6. Find the exact angle DOC in radians. So they're looking for this one here, you probably won't be able to see it. That's where angle DOC, you can see it okay. So what I'm going to do, because these two triangles are similar, I'm going to find this angle here. And I know all three sides of this triangle. Do you see that? Because that's 30. And that's 6. So I'm going to use the cosine rule here. Now, be careful here. We're in radians. Make sure your calculator's in radians whenever you work that out. So the cosine rule, you hopefully know then kind of from GCSE, is a squared equals b squared plus c squared minus 2bc cos a. And you need to rearrange that. So cos of theta, I'm going to call that, and this here is my wee angle theta I'm going to work out, is going to be b squared plus c squared minus a squared. So it's going to be 6 squared plus 30 squared minus 6 root 21 squared all over 2 upon 6 upon 30. Some people like to write out the formula, you maybe should, and we end up with that. So it means my angle cos theta, stick that into your calculator, that all comes out really nicely. It comes out to be a half. And so the angle then that we're looking for, cos the minus 1 of a half, it gives you then pi over 3. Pi over 3, again, you should be reasonably comfortable converting these things. That's going to be then 60 degrees. So that's 60 and that's 60, which means that has to be 60 there. Sorry for talking in degrees whenever it should be radians, but people just find it easier. So that's pi over 3, that's pi over 3. 180 degrees is pi, so we're left then with a pi over 3. So what do we have? We have angle DOC is equal to pi take away 2 pi over 3, and that then just gives us obviously pi over 3 radians. So we know that angle in there now. Find the exact area represented by the ice cream as shown in figure 1. So here's the ice cream here, and so we need to find this. So I don't know if you can spot this. This is just a wee segment. So it's a segment. So we have a formula for segment, or we can do it by finding the area of the sector and take away the area of the triangle. Either of those methods are fine. So some people use this as a half r squared theta minus sine theta. That's fine. Some people use then to kind of find the area of the sector, find the area of the triangle and subtract them. So we'll go for one of those two methods and see how it goes. So I'm going to find the area of the sector first. And we have a formula for that. It's going to be a half r squared theta. And so it's going to be a half. Our radius then was 6 squared. And then our angle then is pi over 3. So that's 18 times by that. So that then gives me 6 pi centimetre squared. One thing I haven't mentioned is you have to leave it as 6 pi. We have been asked for the exact. The area of the triangle then is a half AB sine C, or whatever way you're working it out. So it's going to be a half upon 6 upon 6 upon sine pi over 3. So that's going to be 18, and then this is going to give me then kind of root 3 over 2. Again, you'll just stick that into your calculator and kind of get an answer out, but it ends up giving you 9 root 3. I hope you see what we've kind of worked out here. So 6 pi is everything. The area of the triangle is that we kind of cross-hatch bit, and if we take those away, then we're going to get our ice cream. And they've asked for an exact, remember. So therefore, area of ice cream is going to be 6 pi take away 9 root 3, and that then is centimetres squared.